Today's notes are on 3.1. This is our third day. We're going to be solving quadratic equations by factoring. So far we've learned to use two methods. We've learned solving by graphing, which is 3.1a. And then we've done solving by taking square roots, which is 3.1b. This is also known as inverse operations, right? So solving by graphing works really well when you have, let's say you have a graph. Okay, so if you're given a graph, or if you have vertex or intercept form. And this is because you can find the intercepts really easily from intercept form, or you can find the vertex and use the pattern really quickly to find a graph. However, for this method, the solutions need to be integers, which are also known as whole numbers. Right? If you don't have whole numbers on your graph, then you're going to end up with like this fraction or decimal, and you don't know exactly where it is. So that's a limitation. Now, if we have something that's not a whole number, then we need to find a way algebraically. Solving by taking square roots or inverse operations works best when you have, let's say, vertex form. Or if you have standard form, with no bx. So what does that mean? You can only have like x squared plus 5 equals 0, right? So there's only one x. That you can see. And the solutions can be integers, rational, which is integers or fractions, or irrational. These are like our radicals. Now today we're going to find another way to solve equations in standard form when we have, say, more than just standard form, which is x squared minus 5 equals 10. Right? So now what if we do have a bx? Then we need to do a little bit more. So let's, before we begin, we're going to do greatest common factor and diamond method today. And so let's start at the very beginning. Let's pretend I have given you this equation. Can you confirm that x equals 2 and x equals 1 are solutions? So what we're going to do is we're going to plug them in separately. Okay, so here I'll do the x equals 2, here I'll do x equals 1. So if I plug in 2, that means I have, let's see if I can do it in a different color. So I'll have 2 that I plug in for x, minus 2, and then 2 minus 1. And our question is, does it equal to 0? Well, when we have 2 minus 2, that's going to be 0 times 1, which is equal to 0. Okay, so that's a solution. So therefore, x equals 2 is a solution. Let's say x equals 2 is a solution. Okay, so let's check this one right now. We'll plug in 1. Oops, let me color coordinate again. And you'll notice here we have 1 minus 1, right? So that's going to be 0 as well. So this will be negative 1 times 0. And basically what this is saying is that anything times 0, as long as you have a 0 times, right, then that's a solution. Like anything times 0 is 0. So x equals 1 is a solution. Okay, so this is called the zero product property. And what it's saying is anything times 0 multiply by 0 equals 0. Okay, so what that means is that instead of like trying to guess and check your way through the entire equation, I can focus on just this piece and say, well, if this piece equals 0, that's going to give me one of the answers. And then we can go over here and think of it separately. Well, regardless of what this is, if this second factor equals 0, then this is my other solution, right? And we know there's going to be two solutions because there are two x's. So then we're going to add 5 on both sides. We're going to subtract 10. And we know that this is going to be x equals 5 and x equals negative 10. So this is why when we were looking at intercept form, we switch signs for the x-intercepts. You see, that's really what I did. I said that, well, if I see x plus 10, then my x-intercept is negative 10. And my other x-intercept, which is a solution, is 5. Okay, so this is called the zero product property. Set each piece equal to 0, and whatever your solution is, or x equals, then that is your solution. Let's backtrack a little bit, and before we factor things like that, let's talk about this thing called a GCF. The GCF is called the greatest common factor. Give me a second, let me grab my factor sheet. Okay, so you're going to want your purple factors paper right now because this is going to help you in case you're not the best at dividing. Now, if you can do it in your head, great. So how I start is I usually think about like, okay, so if I wanted to do this in my head, I'd say 12. Factors of 12 is what can 12 be divided by. So 12 is 1 times 12. I know that. It's also, and then I work my way up, right? So 12 divided by 2 is 6, and 12 divided by 3 is 4. So those are my factors, and I list them in order. If you struggle with that a little bit, you can come down here and you see 1, 12, 2, 6, 3, 4. And so I would just write 1, 2, 3, 4, 6, 12 in that order. Okay, so let's do it here for 42. 42 is that one that people often don't catch all of them. So 1, 2, 3, 6, 7, 14, 21, and 42. So what I do is if I don't have something in my head that helps me remember it right away, I do literally just go, well, 1 times 42, right? And I can do 42 divided by 2. That works. So it's 2 and 21. And then I can try 42 divided by 3, which is 3 and 14. And then I would try 42 divided by 4, which doesn't work, right? So I skip it. 42 divided by 5 doesn't work, and 42 divided by 6 works. Okay, so those are my numbers. Now, the greatest common factor, when I say those are my numbers, I mean these are my factors. Okay, all of these are numbers that can multiply to each of these individually. And so what I want right now is the greatest common factor. So the biggest number that they both have in common. So I'm going to work my way down. 12 is not here, but 6 is here. You guys see like that? So your GCF is 6. Now, if you didn't want to write this all out, right, you could just look at 12 and 42 and just start finding the numbers that work the same way instead of writing it out. But for today, let's write it out twice just so that you guys know where it comes from. Okay, so 18. You guys try this and see if you can get, I think it's 9. Let me just confirm. Yep. See if you can get 9. Okay, show your work. See if you can get that correct. So now let's move on to a little bit more complex stuff. Okay, this is stuff that we covered in middle school, so hopefully that seems pretty simple. Now let's just add some variables to confuse you. Okay, so we're going to break down 20 the same way and 30 the same way. So we're going to have 1 times 20, 2 times 10, 4 times 5. Okay, and then afterwards there's that x squared. So you're going to add x and x. Okay, they both have an x in there. They actually have 2. And then for 30, I'm going to go 1 times 30, 2 times 15, and 3 times 10, and then 5 and 6. And so you guys can see here, oh, there's one more x. So what do they have in common? Well, they both have a 10, and they both have an x, right? So our greatest common factor is 10x. So let's take a look at how that looks then. Like, what's the purpose of doing this? Okay, so 2 and 8. Hopefully you could recognize that the GCF of 2, x squared, is 1 times 2 times x, and then 8x is 1, 2, 4, 8, and x. Okay, so they both have a 2 and an x in common. So that means what you can do right here is divide by 2x and 2x, but it's not just dividing, because if we divided, we'd have to divide by something on the other side. So really what we're doing is we're factoring out (2x), and we're going to put it on the outside of the parentheses. Okay, so once we divide, 2 divided by 2 is 1, 2 x's, and 1 crosses out, that's 1x. Then negative 8 divided by 2 is negative 4, and the x's cancel out. If you do this correctly, this last x will always cancel out. Okay, there should be no x's in your last parentheses, or last term in the parentheses. So guys, now we have our factors. Okay, so this doesn't have parentheses, but I could write it like this. And if we follow the zero product property, that says that this first parentheses, if that equals to 0, then that's a solution. And we also know that our second parentheses is if x minus 4 equals to 0, that's also a solution. So I know this one is going to switch signs, right? Add 4, add 4. You don't have to show this part anymore if you don't want to, but I get x equals 4. And then this one, divide by 2, and you get x equals 0. So we have 2 solutions, 0 and 4. Okay, so this one, let's think about this one. They both can be divided by 5. And here's the thing, they don't both have an x anymore. This last term does not have an x. Do you see that? There's nothing there. So we are going to write the 5 as its own factor. And then what's left when you divide by 5? Well, we have x squared minus 2 equals 0. And if we set this, you could set 5 equal to 0, but it doesn't, right? So that's not a solution. And then over here, we can have x squared minus 2 equals 0. In this case, we need to add 2 on both sides. Okay, so this is important. You don't just take the negative 2 and make it a positive 2, because now there's an x squared. So now we have x squared equals to 2. I'm going to square root both sides. And remember that as soon as you square root, you have a plus or a minus, and we don't know the square root of 2. Okay? The last one is very similar, but the only thing now is that you notice it's not equal to 0. If it's not equal to 0, you can't take the GCF, and you cannot set it equal to 0, right? Because it has to equal to 0 for this to work. So the first thing we're going to do is move this positive 12, and we're going to move it over to become negative 12x equals 0, and then the negative 2x squared stays. Okay. Now, I could also move the negative 2x squared to the other side and keep them both positive. So here's the thing I wanted to show you about GCF though. Ideally, you want the first term inside the parentheses to be positive. So what we want to do is, if there's a negative in this first one, you always want to take and divide by a negative. Like, that's the goal, to cancel that out. Okay, I don't care what the sign is of the second one. It's the first one that matters. So they both can be divided by 2, and they both have 1x. Remember, these always cancel out. So now I have negative 2x as my first factor. And then my second factor is written as, let's see, negative 2 divided by negative 2 is 1, and then 1x left. And then negative 12 divided by negative 2 is positive 6 equals 0. So this will be negative 2x equals 0 and x plus 6 equals 0. So this will be x equals negative 6. And then this will be divide by negative 2. Right, so this will be x equals 0. Have you guys noticed that so far it looks like if we have a GCF with an x in it, there's always a 0. Okay, so let's keep going. There are 3 you try problems right now. Okay, so I want you to actually try them. When I come back from being out, I am going to check that you did this and you showed your work. Okay, so I'm going to give you the answers here. But you are going to show your work. Ooh, actually, the answers are at the bottom. Look at me planning ahead. So I gave you the answers to 1, 4, 7, and 10, but you need to get the rest of them correct as well, okay? So here's where you should maybe check with your group at the end of the period, right? You can check in with people the next day. What else can you do? If you are confused, you can try to photo math it. Like, it's not cheating if you're using it to understand, okay? But if it doesn't make sense still, let me know. So GCF works best when you have 2 terms. Notice we've always been working with 2 that can be split into 2 factors. But what if we have A, B, and C in standard form, right? So like something like this. Oh, right here. Okay. So what if we have something like this? Then we can't take the GCF anymore, and it doesn't split it. So what you're going to do is use the diamond method, and you're going to find 2 numbers that multiply to C and add to B. Okay, so keep in mind, C is my last number, B is my middle number, and A in this case, notice we're going to start with A equals 1 for today. Okay, so we're not going to mess with you, and so I'll write this out. When you do your diamond, you're always going to multiply to C and add to B. Okay, so I'm going to do this and set this up on the side. So let me set this up, and I'll put multiply and add for now, just because we're not as comfortable. And I'll put 18 on top. You can think of it as C for ceiling and B for basement. So I'll have 11. Okay, so we need to find 2 numbers that multiply to 18 and add to 11. So I like to do this in my head because I know my times tables, but it's always nice to check, right? So here's my list, and I know that if it needs to multiply to a positive number, this means it's going to be a positive times a positive or negative times a negative. Okay, so positive numbers is we're going to add. So let's find 2 numbers in the 18 list that adds to 11, and that's 2 and 9. It doesn't matter if you write 2 and 9 or 9 and 2, but what you're going to do next is you're going to go x plus 2, x plus 9 equals 0, and then you can switch your signs, right? So this one will become x equals negative 2, and this is x equals negative 9. Okay, let's do another one. This one is a little bit trickier because of the signs, so I wanted to show you guys this one. We're still looking for numbers that multiply to 18. Uh-oh, this was supposed to be a negative 18. I'm so sorry. For this to work, it has to be a negative 18. Can you guys change that, please? Okay, so I need numbers that multiply to negative 18 and add to negative 3. And so we're going to come and check that if we need to multiply to a negative, I need a negative times a positive or a positive times a negative. And what we're doing when we have this is we're subtracting. So I'm going to go to my factors list of 18. And now I know, because the signs are different, I'm going to be subtracting. 18 minus 1 is not 3. 9 minus 2 is not 3. And 6 minus 3 is positive 3. but I want negative 3. So I use 6 minus 3, didn't work. So if that didn't work, what I'm going to do is just go in and change my signs. Okay, so let's check now. Negative 6 times 3 is negative 18, and negative 6 plus 3 is negative 3. So now I have my factors. Please don't jump from the x to here. Okay, that's not allowed. The x is not the algebra. The x is to help you organize. So you're allowed to go from here to here and skip the x, but you cannot go from the x to your final answer. And so we have x minus 6 and x plus 3 equal to 0, and now we see that since it's in intercept form, we have to switch the signs. So people who like to skip from here to here always forget to switch the signs, or they mess up sometimes. It's just not the best. Okay? So this last one is a little bit different yet again, but this time I'm right. Multiply to positive 18. We said positive was positive times positive, or negative and negative and negative times a negative. Okay. But since we're adding, because the signs are the same, we know we want negative and a negative. So let's go back to our factors list. What two numbers add to negative 9 or add to 9? That's going to be 3 and 6. Okay. So we know 3 times 6 works, but that adds to a positive 9. And since I want the opposite, right, I want negative 9, I'm just going to go in and change both of the signs. Always set it equal to 0, because that's the only way that you can switch signs like this. Okay? So now, the hardest part about this is getting your signs right. Okay, and so I want you to check everything carefully. So like once you fill in your x that you think is right, I want you to actually try it and go, let's see, negative 6 times positive 3, right? That equals negative 18, and then negative 6 plus 3, negative 3. And I want you to check each one before you write your factors, intercept form, and get your answer. There are solutions for 3 at the bottom. Okay, do the best you can. And I will be checking for the you try to be complete when we come back.